All right, guys, we are going to continue on with our um, pressure topic that we were talking about before. So last time we talked, it was that um, our pressure is equal to force over area, and we had been looking at PSI, pounds, and our area, and that was in inches squared. I'm just going to write out a word problem based on this, do a little bit with it first, and then we'll go on to a couple of the things for you. So, I'll read this out once I have it all finished. Okay, so this question, let's do placing. All right, Johnny is walking along the ice and it starts to crack. He is 4 feet tall and 75 pounds. We will assume his feet has a dimension of 8 inches by 5 inches. What is the pressure Johnny is placing on the ice? So I could make this into a two-part question, but we're just going to do it as a single question. We're going to take out the important information. If he's standing on the ice, does 4 feet, so his height, really matter in this equation? And I would say no, that it doesn't. Does 75 pounds get used? Yes, it does. Let's put over here. So we know that he is 75 pounds. And the area of his feet is 8 inches by 5 inches. So 8 inches by 5 inches. And we just want to know how much force or pressure. So we want to know, actually the pressure, that not the force, but the pressure. The force would be his weight, the pressure they'd be placing on the ice. So let's erase this now. So pressure is equal to force over area. Our force is 75 pounds. Our area is 8 inches by 5 inches, which is 40 inches squared. Right, 8 times 5 is 40. And it's just a matter of simply pounding out 75 divided by 40. So 75 divided by 40 is 1.875. So 1.875 psi. So that is the force that he's applying. So obviously, you know, if he lays down, he's going to spread out that area from the last question that we talked about in the last video that we did. But that is the force that's going to be applied. Now I'm going to do a slightly different variation question, and I will give you some of these. I'm going to give a little handout, hopefully in lab class, for you guys to go over and see or do some other questions, or I might post them online, one or the other. But in the next week you should see those. Okay, so a rock is on the ground. It exerts a pressure of 10 psi on the ground. If it has a diameter, so if its diameter, it's circular, of 100 inches, how much does it weigh? So important information, 10 psi. Its diameter is equal to 100 inches, and we are actually weigh should be EIGH. So we need to figure out what its force is in pounds. Question mark. Okay. First things first, we need to figure out what the area is because we're not given a straightforward number. So diameter is equal to 100 inches, and I want to know what the area of a circle is and what formula do you use. So if you remember, area is equal to pi r squared, r being the radius, pi being 3.1416 or 3.14, and the radius, so if I looked at a circle, the diameter is all the way across, the radius is half of that. So the radius, if this is 100 inches all the way across, then the radius will be half of that, which will be 50. So 100 divided by 2 would be 50. And so the area is equal to 3.1416 times the radius of 50 squared. So this is going to be a fairly large number because it is in inches. So 50 squared is 2,500 times 3.1416. So we get an area of 7,854 inches squared. And that exerts 10 psi of pressure on the ground. So we can erase this part of it here. So pressure is equal to force over area. The pressure we know is 10 psi. Area we know is 7,854 inches squared. And now we need to rearrange this formula to solve for F. One easy thing when you have a formula like this is you can actually take these values and flip them like that, or if you go back to school, what you did in school, whatever you do to one side, you have to do to the other. Multiply by 7,854 inches squared on both sides. And then this cancels out. Actually, why did I say that? I'm being dumb. I apologize for that. I'm thinking of the last video I did. I just finished off before that. So, 7,854 inches squared. All I need to do, sorry I'm not flipping them, is just move this guy over there. So I just multiply it out on both sides. So I didn't actually need to erase that. Is just get rid of that guy on that side. And we have our force is equal to 7,854 times 10. So the weight of that rock is 78,540 pounds. So that is an extremely large rock. So it would be an extremely tall rock if it's putting a force of 10 pounds per square inch. Okay, but that's how essentially you would calculate out that question. So I'll give you a few questions later on that. Next, what I want to go through is the some different values here. So we're going to use 1 psi as our base. 1 psi is equal to 27.7 inches of water column. So 27.7 inches of water column is a value that's used for gas pressure. So if you were looking at gas pressure coming into a house ends up seeing 7 inches of water column. So 7 inches is about a quarter of 27.7, so there's about a quarter psi of natural gas that comes into a house. But that is what is used to calculate that. So if you have a column of water, and what this means is if you have a column of water that's 27.7 inches tall, at the bottom it's going to see a pressure of 1 psi. The next one we're going to look at is kilopascals. There are 6, and this is used in weather, 6.895 kilopascals, and that's also what's used in, rather than PSI, but on gauges in cars now. When you look at your tire pressure, so you should see around, and it's around 200 to 240 kilopascals. So that would mean that there's 6.895 kilopascals in 1 psi. The next one down is bar, and bar is equal to 0.0689. So 1 psi is 0.0689 bar. If you notice, these values are very similar. They use the same 689. And the last one we are going to do is our mercury, and that is 2.04 inches of mercury, which I believe is Hg. Yeah, so Hg. So that's our mercury. So inches of mercury. So if I have 2.04 inches of mercury in a bowl, it'll exert 1 psi on the bottom of the container. 27.7 inches of water, and these are physical things you can see. But this is the way to go in between them, and a lot of times you would end up having to go from your 27.7. So if you wanted to go to inches of mercury, a lot of times you'd have to go from 27.7 inches of water to 1 psi, and then go from 1 psi to 2.04 inches mercury. So I'm going to go through a couple questions on that now, but I'm going to erase the big board here. I'm just going to keep these values off to the side. So we have 6.895 kPa, 0.0689 bar, and we have 2.04 inches mercury. So they all revolve around all those, I guess, 1 psi. They all equal the exact same thing. and I'll show you a neat way to end up bouncing in between all of them. So let's first say I have 87 inches of water column. So I have 87 inches of water column, and I want to know how many psi that is. So the easiest way to do these is looking at, so I want to know psi, question mark. The easiest thing is to do what they equate to. So I'm going to put 27.7 inches of water column here, and that is equal to 1 psi. This, I now have 87 inches is what I'm working with, and it equals an unknown psi. This is the easiest way to do these. So this ratio has to be equal to this ratio because I'm asking what the equivalent amount is in psi, and this is the equivalent psi if I only had 1 psi. So what you do here is I cross multiply. Maybe this will make sense. I don't know if I garbled that up. I cross multiply these two. So 87 times 1. So 87 times 1 is equal to 87, right? So we have 87. So I cross multiply and then divide by the only other number that's left. So I divide that by 27.7. Right, so I'm going to throw that into my phone now. 87 divided by 27.7 is 3.1408. So now I erase that. So that equals 3.1408. So we'll round that up to 3 decimal places. So it equals 3.141 psi, just like that. So if I end up taking if I take 27.7 inches water column divided by 1, if I actually did these equations out just to check if I was right, 27.7 inches divided by 1 is going to equal 27.7. And if I take 87 and divide it by 3.141, it will also equal 27.7. That's why I can do an equation like this, because I'm just balancing it. So it's this ratio ends up equaling that ratio, and this is the number that you're asked for, the 3.141. And it's as easy as that. Okay? So next thing that I'm going to look at, I'm just going to do a couple more of these. I want to know how many we have. Let's do what the conversion would be for a vehicle. So let's say you're supposed to have 208 kPa. And this is something too, if you're going to go to a gas station to put air in your tire, and let's say you don't have a gas gauge with you, but obviously when you get back in your car, you're going to see if the level is right. I need this as my kPa, my kilopascals, and so I go out and I go to put in my, I'm going out to fill it up, and that's what I need, 208 kPa, and I want to know what that is in PSI. So 208 kPa PSI right here. And then we're going to do 6.895 kPa here and 1 PSI. So just like I was saying before, I don't know why I made that capital and that one small. I multiply the two things across from each other that I have. So 208 times 1 is 208. And I divide by 6.895. 208 divided by 6.895, and that gives me a value here that equals 30.166. I guess it'd be 167 psi. So about 30 psi. So 30.167 psi. So that's fairly straightforward, but then I'm going to tell you now that, and the reason why you wanted to go out is because those little, a lot of the tire gauges, the ones that you can buy, and also the ones on the air hoses when you go to fill them up, they have a value in PSI. So your car might say it in kPa, or your truck, and the low gauge is going to say it in PSI. And you get there and it says that it is roughly, as close number as you can see, it says that there's 17 psi that is in your tire. So right away you know it's almost half, but we want to look to see exactly what it is. So we found out that we had 17 psi. And we're trying to convert it back to kPa. So question mark for kPa. That equals 1 psi over 27.7 inches, or what am I saying? Over 6.895 kPa. So we multiply across the things that we have. So across of what we have. So 17 times 6.895 kPa, and then that gives us a value of 117,215. And what happened there? Something happened there. Times, I didn't put the decimal in. So that should be 17, or 117.215. So we multiply across, then divide by 1. So we end up finding we have 117.215. 215 kPa of what is actually in the tire. So that's in the tire, and that was what was needed. Alright, I'm just going to erase this, and I'm going to just put a couple conversions on here I want you to do yourself, and we can take them up next time. I want you to do 2.0, 20 inches, 20 inches of mercury to 1 psi, and then 20 inches of mercury, and you'll have to do a double step here. 2 inches water column. So doing this step first will help you go to the other side. And then I want 1 bar to PSI. And then I want, so this one will be a little trickier, but I'll use smaller numbers. We'll do 15 kPa, 15 kPa to inches of water column. So you can do those before the next class, just as practice, our lab class, and then we'll take them up. Just remind me so I don't forget. All right, you guys have a good day. All right, bye.